All right, welcome back. We're going to dive into 10.2. We're going to talk more about angles, but we're going to apply them to triangles. So down here we have that the sum of the measures of the three angles of any triangle is 180. So if I have a triangle, I'm saying that if I add these interior angles together, it's going to get to 180 degrees. So I just want to show you a little visual of why, help you see. So if I have these angles, angles 1, 2, and 3, they're all within a triangle that I made out of paper here. And I'm going to rip the angles off of the triangle. So I now have my triangle angles all separated. So if I take these angles and I line them up, I expect them to add to 180, So I would expect for them to form a straight line. So if I line up these angles, if I put them together carefully, then these three angles together are making a straight line down here. So in fact, these three angles make a triangle, and if I rip them and put them together point to point, they do make a straight line. So we have that the measures in any triangle add up to 180 degrees. I'm going to go to the next page. So if I were to give you a problem where I give you two angles inside the triangle, we just need to find the third angle that would make them add up to 180. So a bunch of ways you can do this, but if you take 120 plus 17, which are the two angles that you know, we're going to add those together and then take that away from 180 degrees. So we get 137. If you take 137 away from 180, you're left with 43 degrees. So this angle would be 43 degrees. We can do a similar thing with question 5. However, there's lots of things going on. So we need to kind of jump around this picture to try to find all of the angle measures. I'll just try to go in order as best I can, and we'll see how that goes. So angle 1 and this angle here, this one marked with a right angle, making it 90 degrees. These are a linear pair. They're forming a straight line. So these two angles are going to add to 180 degrees. 90 is what would do that. So these two angles are a linear pair. So if we add them together, we should get 180, and 90 is what would do that. So that is also a right angle. If we focus in on this triangle, I know two of the three angles within this triangle. So I know these two angles, 90 and 43. I need to find the third angle. So we do 90 plus 43, which gives us 133. Take that away from 180, and we're left with 47 degrees. So angle 2 is 47 degrees. In addition, angle 3 is also going to be 47 degrees, and that's because these angles are vertical angles, which are also congruent. So 47 degrees. If I look at the next triangle, this one up here, I now know two of the three angles within this triangle. I know this one is 60, this one is 47, and I know that all three of them together need to add to 180. So 60 and 47 together give you 107. And we take that away from 180, and that leaves us with 73. So I know that angle 4 is going to be 73 degrees. Now 4 and 5 are a linear pair, so they should expect to add to 180 degrees. They're forming a straight line. So 180 minus 73 is 107. So angle 5 is 107 degrees. So that kind of puts together all of the different things that we've learned. Linear pairs, supplementary, angles in a triangle are 180, vertical angles are congruent, and we kind of put it all together in one problem. Down below, we're going to classify triangles. So we can classify triangles as equilateral, meaning equal side lengths. So an equilateral triangle will look like this, where all three sides are the same length. And what's kind of neat about triangles, if you have all three sides the same length, then we know that all three angles are going to be the same measure. So all angles are, so they're all three the same measure, and we have 180 total. Divide 180 by 3, and each angle is going to be 60 degrees. An isosceles triangle is a triangle that has two sides congruent. So in an isosceles triangle, it's going to be something like this. Two sides are congruent. I'm marking them with one dash, indicating that they're congruent. And in this triangle, if you have two sides congruent, then we know the base angles are congruent. So if these sides are congruent, these angles are also going to be congruent. Our last category of triangle based on side length is scalene. And a scalene triangle is just a triangle where all three sides are different lengths. So all sides different lengths. And we don't have any nice properties of scalene triangles because they can look so many different ways that we don't have any nice relationships with those. Acute triangle just means that it has three acute angles. Obtuse needs to have one obtuse angle. And a right triangle is going to have one 90-degree angle, one right angle. So for an acute triangle, all three angles must be smaller than 90 degrees. So something like this. Maybe 55, 80, and 45 would work. So they have to add to 180. They have to add to 180, but also to be acute, they all have to be less than 90. For obtuse, one of our angles needs to be bigger than 90 degrees. So if this angle is something like 140, that's a pretty big angle, then maybe this one is 25, and that would make this one 15, and that would make an obtuse triangle, noticing that they have to add to 180 degrees, and one has to be obtuse. A right triangle is going to be any triangle where you have you have one 90-degree angle. For similar triangles are going to be triangles that have the same shape, but they have different side lengths, so different measures. So they're not the same size, they're just the same shape. So similar triangles are used in scale drawings. So if you think about an architect is going to draw a house, they're going to take the house and they're going to scale it down onto a piece of paper so that you can understand like the relative size of everything within the house. You're not going to draw the full-size house on a piece of paper. That would be overwhelming. So they take and they scale everything down. They make it all smaller to fit. Or you can think about like a model airplane. It looks just like the normal airplane, but now it's been scaled down. And so we can do the same thing with just polynomials, okay, shapes here. So similar triangles, it's like a scale drawing. You take this bigger triangle, you scale it down to fit on your piece of paper. Or you have an architect plan and you scale it up to build the house. So similar triangles are the same shape, but different size. So same shape, meaning we have all the angles the same, but their sides are not. So we have corresponding sides, corresponding angles, we'll start with those, are congruent. So if you see in our picture, angle A is congruent to angle D. Those are corresponding angles. They're in the same location. So A and D are the same size. We also have C and F are the same size. And we have B and E are the same size. Those are equal in size. Our sides, however, are not equal in size. So 6 and 3, those are not the same. 3 is half of 6. 8 and 4, same thing. Not the same, but they do have a relationship. So we have that corresponding sides are in proportion. Corresponding sides are proportional. And what that means is if you divide them, you should get the same thing. So it doesn't matter whether you start with the big or the small triangle, but if I do 6 this side over 3, those are corresponding sides, it gives me 2. And if I pick any other pair of corresponding sides, like those, 8 over 4 should also give me 2, and it does. And that works for all 3 pairs of our sides. 4 divided by 2 is also 2. That shows that our sides are in proportion. So although our sides aren't congruent, they are proportional in their relationship, which can help us find side lengths if we're missing them. So at the top it says, in triangles, if 2 triangles have 2 pairs of congruent angles, so 2 pairs of congruent angles, then the third pair of angles are congruent and the triangles are similar. So if you have 2 pairs of congruent angles in a triangle, the third is also congruent, okay, and the triangles are similar. So if we look at, if I have 2 triangles, maybe they're the same size, we'll try to make them look the same shape or so, and I know that this angle is congruent to that one, and this one's congruent to that one. If I think about maybe some numbers, like 140, those are the same, 140, and maybe this one is 25. So I know I have 2 pairs of congruent angles within these triangles, so I know the third has to also be congruent. If you think about if you did 140 plus 25, and then took that away from 180, you'd get 15. And you do the exact same thing down here, and you'd get 15 again. So either way, if you've got 2 angles that are the same, 2 pairs, then the third is going to be the same as well. And that's what the statement at the top of the page is saying. Down here it says, explain why the triangles below are similar and find the x value. So we know that this angle and this angle are congruent. That's given to us. This angle and this angle are congruent because they're vertical angles. And we know that the third pair of angles is congruent because of this statement at the top. So why are the triangles below similar? All 3 angle pairs are congruent. And we used vertical angles. And the third angle property, which if you want to draw an arrow is what's listed up there. So these are going to be similar triangles because all 3 pairs of angles are congruent. Now in order to find a missing side length, we know that our sides are not equal, we know they're in proportion, and so we're going to set up a proportionality statement in order to find that side. So we want to take x, which is what we're trying to find, and we're going to compare x to its corresponding side. So if I take x divided by 7, that should be the same as, it should be in proportion as 8 divided by 5. So I went big triangle to little triangle, big triangle to little triangle, setting up corresponding sides into a proportion. To solve a proportion, you can cross multiply. So x times 5 is 5x. And 8 times 7 is 56. Divide by 5, and x is 11.2. For question 7, we can do the same thing. So on question 7, these triangles are going to be similar for the same reason above. We've got a pair that's already identified as congruent. These are vertical angles. And then we have that third angle property that says that these would also have to be congruent. So we do have similar triangles. In order to find our missing side, we're going to take x and divide it by its corresponding side in the other triangle, which is 10. Since x came from the bigger triangle, we need to put this side on top. So x over 10 should be the same as equal to 12 over 8. And I'm going to cross multiply to solve this. So x times 8 is 8x. 10 times 12 is 120. And when you divide by 8, x is 15. All right, one more question here. We've got a man who is 6 feet tall, standing 10 feet from the base of a lamppost so that their shadows line up. The man's shadow has a length of 4 feet. How tall is the lamppost? So we have this image. Although it's hard to tell, we do have two triangles here. We have this triangle involved with the lamppost and its shadow, like this. And we have a second triangle of this guy standing there. So we do have two triangles, they just overlap. So I'm going to take these triangles and pull them out of the picture and draw them off to the side so I can see them a little bit better. So I have my large triangle that uses the lamppost. This side is x, and this side is not 10, it's 14. 10 plus 4. My smaller triangle is made of the man and his shadow. We have this is 4 feet and this is 6. A question we might have is, are these similar? So let's look at what we know. We know the lamppost, or we hope the lamppost intersects the ground at 90 degrees. The man is standing straight up, so his is also at 90 degrees. Inside this triangle, this angle is the same. This one and this one, it's the same exact angle right here. They were on top of each other. They have the same angle. And we know these angles are congruent by the third angle property, which we listed above. So now that we know the triangles are similar, we can find their side lengths using a proportionality statement. So if I start by taking x, which is my lamppost, the corresponding side in this image is 6 feet. That should equal, since x came from the larger triangle, we're going to put 14 on top, divided by 4. So x over 6 should equal 14 over 4. If we cross multiply to solve this, 4x equals 84. And divide by 4 gives us x is 21. Alright, I know this is a lot to go over, but I'd like you to try your homework now so that you know if you have any questions over this. I think a lot of it's intuitive, maybe not this similar triangle stuff, but most of it's probably stuff that you've heard before. It's just a matter of practicing it. Thank you for watching. Once again, sorry about not being able to be in class, and if you have any questions at all, please do not hesitate to email me, and please bring questions with you to class on Thursday. I'll be happy to answer them all together. Thank you, and I hope you enjoy your day off.